So we said that there are lots of different types of anemias. And the anemias can be grouped up into two, can be divided up into two large groups, into one group called the underproduction anemias, and the second group called the destruction anemias. And the underproduction anemias are anemias that are due to a problem with making the red blood cells. So somewhere along the way, there's a problem with making enough red blood cells. Versus with destruction anemias, you have healthy red blood cells being made in sufficient quantities, but these red blood cells are subsequently being destroyed, either by our immune system, by viruses, or they're being lost in some way. So we said that one of the ways that we can tell whether we're looking at an underproduction anemia or a destruction anemia is to look at the reticulocyte count, where the reticulocyte count is a measure of how many reticulocytes we have. And reticulocytes are young, immature red blood cells, right? So with the destruction anemias, we said that the reticulocyte count, I'm just going to abbreviate that, retic, right? So retic count is higher. So it's greater than 3%, with 3% being the normal reticulocyte count. So with destruction anemias, the reticulocyte count is greater than 3%. And that's indicative of a bone marrow that's working really hard to replace the lost red blood cells. Okay, so it's churning out these young, immature red blood cells to replace the ones that have been lost to destruction. Now, compare that with the underproduction anemias, where the reticulocyte count is lower. So it's less than the normal 3%. And that's because we have, with underproduction anemias, we have a problem with making red blood cells. So you're not going to see a bone marrow that's appropriately responding by increasing red blood cell production, right? Because to begin with, the problem is a production in red blood cells. So initially, the anemias are split up into underproduction anemias and destruction anemias. Now, these underproduction anemias, we said that there are many different causes of underproduction anemias. These can be further subclassified based on the size of the red blood cell. So before we go into any more depth about that, let's take aside to say that the normal size of a red blood cell is measured by an index called the MCV, where MCV stands for mean corpuscular volume. So mean the average volume of a red blood cell. And the average MCV, the normal MCV range, is between 80 and 100. So a normal red blood cell falls anywhere between 80 and 100. Now, the underproduction anemias can be subclassified into anemias where the red blood cells are larger than normal, are smaller than normal, and are of normal size. Okay, so let's talk about the first group, where the red blood cells are larger than normal. So in that case, the MCV would be greater than 100, right? Because 100 is the upper limit of normal. And these anemias are called the macrocytic anemias, where macro means large and cytic means cell. So these are large red blood cell anemias. The second group, where the red blood cells are smaller than normal, right? We'd expect to see the MCV, the mean corpuscular volume, less than 80, because 80 is the lower end of normal, right? And these anemias, these are called the microcytic anemias. Microcytic anemias. Micro meaning small, cytic meaning cell. So these are small red blood cell anemias. And then finally, the group of normal size red blood cells, that's the MCV of those cells falls between 80 and 100, right? So right within the normal range. And these are called normal cytic anemias. So normal red blood cell size anemias. And we're going to go into the different causes of macrocytic, microcytic, and normocytic anemias, the different types of those anemias. But as a general rule of thumb, the macrocytic anemias are caused by a shortage of DNA precursors. So anything that causes a shortage of DNA precursors will lead to a macrocytic anemia. Okay, compare that to a microcytic anemia. General rule of thumb is microcytic anemias are caused by a shortage of hemoglobin, right? Impaired hemoglobin production, whether that's not enough hemoglobin being formed or abnormal hemoglobin formed, whatever the cause, there is a problem with making hemoglobin. Whenever you have a problem with making hemoglobin, that leads to a microcytic anemia. And pretty much all of the other underproduction anemias fall into the realm of the normocytic anemias. Okay, so we're going to go into specifics about the different types of anemias, but this diagram is a very good paradigm into organizing your thinking about the different types of anemias. And as we go along, it's important to sort of place the anemias where they fall within this diagram, because it helps you to keep them organized in your mind.